Hi, this is Rick for EDU Mobile. Now we're going to talk about classes and structures. Kind of an overview of these. There'll be a couple of discussions before a demo. But the first discussion here is going to be an overview on classes and structures. And then we're going to talk about properties. And then we're going to talk about methods. So here we go. What do they have in common? We know that classes and structures have a great deal in common. They can both define stored and calculated properties. And remember, enumerations can only define calculated properties. Both classes and structures can define methods. They can both define something called a subscript for the properties to make them easier to access potentially. They can define initializers to set up properties. In Objective-C, we have init or init with. In other languages, we have constructors. Both classes and structures may have these initializers. Both classes and structures can use something called an extension to extend their functionality, and both can adopt protocols also to adopt certain behavior from other things. So what do they not have in common? Well, when we talk about what they cannot have in common or do not have in common, what we're really talking about is what happens because structures are value types and classes are reference types. Reference types, classes, can be introspected. Classes have an is and an as operator, and we'll talk about those as we get deeper into the course. Classes can be polymorphic. In other words, an instance of a class can be treated as an instance of another class in that same class hierarchy. Structures obviously can't do this because structures can't substruct from another struct, let's say. But classes can have a class hierarchy because a class can be a subclass of another class. By the way, in Swift, I think I should mention now that if you do not subclass another class with your class, it is not a default subclass of some other object. Remember that in Objective-C, we have NSObject, which is the ultimate root class, if you don't subclass a class. In Swift, if you don't subclass a class, that is a root class. So our hierarchies of classes always begin with a class that we define. Our own hierarchies, like let's say we're defining a model in a model view controller, that class, the root class there, would be an ultimate root class. Classes can be deinitialized. In other words, classes can define a method called deinit to clean up when an instance is deallocated. Structures can't do this because structures, again, are value types. They're not allocated on the heap, therefore they can't be deallocated. And structures, finally, cannot participate in reference counting. Only reference types, and that should be very obvious, only reference types are reference counted. Classes are, structures aren't. Okay, let's go on. To declare a class, it's very simple. We declare it with the class keyword. We have properties and methods. A class, because it defines a new type, should be capitalized and in camel case. So here we have class myClass with its properties and methods. So what's the difference between class syntax here and a property syntax? Well, we have the struct keyword, and that's it. That's all. So here we have struct myStructure with its properties and methods. It defines a new type. It should be capitalized in camel case as well. So going back and forth, we see that the only thing that is different here is that one uses the keyword class and the other one uses the keyword structure. So Swift gives a couple of different names to some concepts that we're already familiar with. If you're familiar with object-oriented programming, the word object is applied to describe an instance of a class only. And that holds in Swift too, but we need another word to describe an instance of an enumeration or a structure or a class. Swift uses the word instance to describe a, quote, object of either structure or class or enumeration type. So just using this word instance. instance of a class, instance of a struct, instance of an enumeration, even though these aren't reference types, not all of them, we still use that word instance. Again, in Objective-C, methods that operate on a class object are called class methods. But because these can occur in structures and classes, not enumerations by the way, Swift names them type methods. They occur in a type. We also have type properties as well, and they're declared in a similar fashion to type methods. So how do we instantiate? Well, if we have a class, we say let or var my class instance equal my class with a parenthesis. If we have a struct, we say let my struct instance equal my struct with parentheses. In other words, the initialization or the instantiation is the same. In both cases, we're calling the type's initializer. It's init method. Now, if a type is defined without an initializer, if it doesn't have an inits method, a couple of things have to be true. First of all of its properties, all of its stored properties, which we'll get to when we talk about properties, all of those have to have a value when it's initialized. In other words, they have to have a value assigned to them at declaration time. Otherwise, you must define an initializer, your own, to initialize those values. But if that's true, then a default initializer called init will be used. And you don't have to write that as long as you have property definitions with your declarations. Note that above, the class and the structure instance are constants. Now, let's talk about what happens when we do this. If we set up a class constant, if we say let my class instance equal my class, and my class is a class, we hope so, then the properties of that class will still be mutable. It's a reference type. The class itself, in some fundamental way, is immutable, but its properties are mutable as long as they are var properties. If we make a constant structure, though, even if its properties are var properties, they are immutable because a structure is a value type. Okay, so typically if we want to change the values of a structure, we need to make it a var structure. But if we need to change the values of a class, all we need to do is ensure that the values that we want to change are var properties. Okay, going on. Let's talk a little bit about something we've been mentioning for a while but haven't really dug into. What is a reference type? We know that structs and enums and everything else are value types. Reference types behave differently. First of all, they're on the heap. If you don't know what that is, that's okay. It's not important. But secondly, when we assign a reference type, it creates a new reference to the same instance. In other words, it's not a copy. It is a, if you will, a pointer to the same thing. It's not really a pointer, but it's a reference to the same thing. So if we pass a reference type to a function, we're passing the actual instance to the function, and we can modify it into the function. So passing a reference type to the function is like passing a value type as an in-out parameter to a function. Same kind of thing. So, but by default, passing a reference type to a function passes the actual reference to the instance that we're referring to. Passing a value type to a function by default just passes its value to that function. And the same goes for methods. Now, modifying an assigned or passed instance of a reference type modifies the instance that we're referring to. If we say we have a class, an object, an instance A, which refers to a class type, and then we say B equals A. Now we do B dot whatever, some value, equals 19, and then look at A's some value, it will be 19 as well. In other words, we are changing A. We're just referring to it with a different reference. Of course, we know that we modify a value type. If we modify a property of a struct and then copy it and then change some value, the original won't be changed. This is value type. Reference types are, finally, reference counted. When a reference counts reach 0, the instance is going to be deleted by automatic reference counting. Obviously, value types cannot participate in automatic reference counting because they're not reference types. When do we use a class and when do we use a structure? Well, basically, we want to think about using structures if we want to store a few properties that are well known, and those properties are themselves value types. Storing the coordinates of a point would be a good candidate for a structure. We want to copy that point someplace else. We might want to change the copy. That's a good candidate for a point, or for a structure. And you want copy behavior for the structure and its properties. In other words, you want to store some discrete values. You might want to have some methods on them, add 2 points, or add 2 vectors, or find the distance between 2 points. All of these are good candidates for a structure. Use classes for everything else. And that's the simple rule. And of course there's exceptions, but we'll see those and we'll spot them as we go along. So there's a lot more to cover with classes and structures, obviously. We haven't talked about properties and methods. We mentioned a magic word subscripting that we didn't even define. We have inheritance behavior to talk about for classes, and extensions for structures and classes, and protocols for structures and classes. So there is a lot more to deal with. Thank you very much.